Now let us know about different formulae to calculate the number of moles. To calculate the number of moles of atoms, this formula is used. That is, number of moles of atoms is equal to weight in gram divided by atomic mass. To calculate number of moles of molecules, this formula is used. Number of moles of molecules is equal to weight in gram divided by molar mass. To calculate number of moles of molecules, this formula is used to calculate the number of moles of molecules is equal to number of molecules divided by Avogadro number. Number of moles of atoms is equal to number of atoms divided by 6.022 into 10 to the power 23. Number of moles of gases is equal to volume of gas at STP in liters. STP means standard temperature and pressure in liter divided by 22.71. These are the formulae to calculate the number of moles. Okay, let us take some problems. Calculate the mass of one carbon 12 atom in gram. Gram atomic mass of carbon 12 is 12 gram. That is, atomic mass of carbon 12 in gram is 12 gram. That is, the mass of 6.022 into 10 to the power 23 atoms of carbon 12 is equal to 12 gram. That means Avogadro number of atoms of carbon 12 weighs 12 gram. Therefore, mass of one atom of carbon 12 is equal to 12 divided by Avogadro number. 12 into 10 to the power minus 23. If it goes to the numerator, this become minus 23. 12 into 10 to the power minus 23 gram divided by 6.022. This is equal to 1.99 into 10 to the power minus 23 gram. This is the mass of one carbon 12 atom in gram. Calculate mass of one molecule of water. We know that molar mass of water is 18 gram per mole. That is, oxygen is 16 plus 2 hydrogens are there, 2 gram. 16 plus 2 means 18 gram per mole. That is, mass of Avogadro number of molecules of water weigh 18 gram. Therefore, mass of one molecule of water is equal to 18 divided by Avogadro number. 18 gram divided by 6.022 into 10 to the power 23, which becomes equal to 2.99 into 10 to the power minus 23 gram. This is the mass of one molecule of water. Calculate the number of atoms in 52 moles of argon. Here we need to remember number of atoms in 1 mole of argon, any substance, always is equal to Avogadro number. Here it is argon. So number of atoms in 1 mole of argon is 6.022 into 10 to the power 23. Therefore, number of atoms in 52 moles of argon means this Avogadro number should be multiplied by 52 moles of argon. Then we get 3.13 into 10 to the power 25. This is the number of atoms in 52 moles of argon. Calculate the number of atoms in 52 unified mass of helium. See here, atomic mass of helium is expressed in unified mass, that is U. Since atomic number of helium is 2, atomic mass is 4, hence atomic mass of helium is 4U. Therefore, number of atoms in 52 U of helium is 52 divided by 4. Then we get number of atoms in 52 U of helium, that is 13. Calculate the number of atoms in 52 gram of helium. Here atomic mass of helium in grams is 4 gram. Number of moles in 52 gram of helium means 52 divided by 4, that gives 13 mole. But here we need to calculate number of atoms in 52 gram of helium. Therefore, number of atoms in 52 gram helium is equal to this 13 mole should be multiplied with Avogadro number of particles. That means 13 into 6.022 into 10 to the power 23. This will become equal to 7.83 into 10 to the power 24. This is the number of atoms in 52 gram of helium. Calculate the number of moles of carbon atoms in 2 moles of ethane. Ethane formula is C2H6. Number of moles of carbon in 1 mole of ethane is equal to 2. This is the 1 mole of ethane. Here the number of moles of carbon is 2. Therefore, the number of moles of carbon in 2 moles of ethane means this 2 should be multiplied with 2, because for 1 mole of ethane number of moles of carbon is 2. For 2 moles means it should be multiplied by 2, then it gives 4. 4 is the number of moles of carbon atoms in 2 moles of ethane. Calculate the number of moles of hydrogen atoms in 2 moles of ethane. Here the number of moles of hydrogen atoms in 1 mole of ethane, that is C2H6, is 6. Therefore, the number of moles of hydrogen atoms in 2 moles of ethane means this should be multiplied with 2. That is 2 into 6, that becomes 12. That means this is the number of moles of hydrogen atoms in 2 moles of ethane. Which of the following will have largest number of atoms? 1 gram silver, which is solid, 1 gram potassium, which is solid, 1 gram lithium, which is solid, 1 gram oxygen, which is gas. Here they have given atomic masses of silver is 108, potassium is 39, lithium is 7, oxygen is 16. Solution. Let us see the solution. 1 gram of silver is equal to 1 divided by 108 mole. That means if you want to convert 1 gram of silver in mole, that should be multiplied by divided by atomic mass of silver, that is 108. That means 1 divided by 108 mole, which is equal to 1 divided by 108 into 6.022 into 10 to the power 23 atoms. If you want to convert mole in terms of atoms, this mole should be multiplied by Avogadro number. Then we get number of atoms present in 1 gram silver. Similarly, the number of atoms in 1 gram potassium is equal to 1 divided by 39. 39 is the atomic mass of potassium. Then we get 1 divided by 39 into Avogadro number of atoms. Similarly, 1 gram of lithium is equal to 1 divided by 7 mole. 7 is the atomic mass of lithium. This gives mole. To convert into atoms, number of atoms, we need to multiply this 1 divided by 7 by Avogadro number, that is 1 divided by 7 into 6.22 into 10 to the power 23 atoms. This is the number of atoms present in 1 gram lithium. One gram oxygen is equal to 1 divided by 32 mole. To convert gram in mole, this gram should be divided by atomic mass of oxygen, that is 32. Actually, one oxygen means 16. Here two oxygen atoms are there, that is so it is 32. 1 divided by 32 into Avogadro number of molecules, that means 1 divided by 32 into 6.022 into 10 to the power 23 molecules. This is the number of molecules present in 1 gram oxygen, but we need number of atoms, so this value should be multiplied by 2, then we get, because here two oxygen atoms are there, hence 1 divided by 32 into Avogadro number into 2 atoms. 2 1 ja 2 16 ja, that means 1 divided by 16 into Avogadro number. This is the number of atoms present in 1 gram oxygen. You can see here 1 gram of silver contains this many number of atoms, 1 gram of potassium this many number of atoms, 1 gram of lithium this many number of atoms, 1 gram of oxygen this many number of atoms. But here, which contains largest number of atoms? Here the smallest value is this one in the denominator, that is 7. This value become more compared to this and this, because in the denominator 7 is there, but here 108 is there, 39 is there, 16 is there. This will give highest value among these four, hence 1 gram of lithium contains largest number of atoms. Calculate the number of atoms in half a mole of N2 gas. Here 1 mole of N2 gas contains Avogadro number of molecules. So half means 0.5 mole of N2 gas contains Avogadro number divided by 2. That will give 3.011 into 10 to the power 23 molecules. This is the number of molecules present in 0.5 mole of nitrogen. But here we need to calculate number of atoms. So since nitrogen is diatomic, the number of atoms of nitrogen is equal to this number of molecules should be multiplied by 2. Then it gives 6.022 into 10 to the power 23 atoms. This is the number of atoms present in half a mole of nitrogen gas. Calculate the number of atoms in 5.68 liters of helium gas at STP. Number of moles in 5.6 liters of helium at STP is equal to 5.68 liters divided by 22.71. Okay, here since this is gas, it should be multiplied divided by 22.71. This is the volume of gas at STP. But here the volume of helium is given is 5.68. If you divide 5.68 by 22.71, then we get number of moles of helium at STP, that is 0.25 mole. Number of atoms in 0.25 mole of helium gas is equal to Avogadro number into 0.25, that gives 1.51 into 10 to the power 23 atoms. Since helium is monoatomic, number of atoms in 0.25 mole is equal to this much only. If you multiply this one, that value will become this only, 1.51 into 10 to the power 23. This is the number of atoms in 0.25 mole of helium gas. A molecule of diatomic compound weighs 4.98 into 10 to the power minus 23 gram. What is its molecular mass? How many molecules are present in 30 kg of this compound? Here weight is given, the molecule is diatomic. We need to calculate molecular mass and how many molecules are present in 30 kg of this compound. Here first we need to calculate molecular mass. Molecular mass of this compound is equal to 4.98 into 10 to the power minus 23 gram into Avogadro number. This gives 30 gram because molecular mass is equal to weight into Avogadro number. Number of moles in 30 kg of this compound is equal to 30 kg means 30 into 10 to the power 3 gram divided by molecular mass means this one. How much is there? 30 gram divided by 30 gram. That gives 1000. This is the number of moles in 30 kg of given compound because number of moles is equal to weight divided by molar mass. Here we need to calculate how many number of molecules are present in 30 kg of compound. That is, number of molecules in 30 kg of this compound is equal to number of moles, this one, into Avogadro number. That means 1000 into 6.022 into 10 to the power 23. This will give 6.022 into 10 to the power 26. This is 10 to the power 3. This is 20 to the power 23. That will become 10 to the power 26. This is a number of molecules present in 30 gram of a given compound.